In this lecture, we'll study about examples on homogeneous solutions with characteristic root of multiplicity m. Okay, so come to example 1. Find the homogeneous solution for the difference equation. So this is a third order difference equation and we'll find out the homogeneous solution for this. Okay, so let us write down the characteristic equation for this third order difference equation. So it can be written as alpha q plus 6 alpha square plus 12 alpha plus 8 is equal to 0. Okay, so this is the characteristic equation. Okay, so now we'll find out the roots of this particular equation. Okay, so see here, by inspection it is clear that if you put alpha is equal to minus 2, okay, so this will be, if you put alpha is equal to minus 2, this will be minus 8 plus, this will be minus 2 to the power 2 is 4, this is minus 8 plus 24 plus minus 24 plus 8. So this plus 24 minus 24 will be cancelled out, this minus 8 and 8 will be cancelled out. Okay, so by inspection it is clear that alpha is equal to minus 2 is the root. Okay, alpha is equal to minus 2 is the root. Alpha is equal to minus 2 is the root, so we can write alpha plus 2 is one of the factor of this particular equation. Okay, so we can write it down like this. Alpha q plus 6 alpha square plus 12 alpha plus 8. We will divide this one by alpha plus 2. Okay, so quotient is alpha, so this will be alpha square, this will be alpha q plus 2 alpha square minus, this will cancel out, this will be 4 alpha square plus 12 alpha. Now we have 4 alpha, and this will be 4 alpha square plus 8 alpha, cancel out, this is 4 alpha plus this 8. Now we have 4, so this will be 4 into alpha plus 2, that is 4 alpha plus 8 equal to 0. Okay, so this equation can be written as alpha plus 2 into alpha square plus 4 alpha plus 4 equal to 0. So this is the formula for a square plus 2ab plus b square. For a is alpha, b is 2. So this is alpha plus 2 whole square is equal to 0. Okay, so which implies we have alpha plus 2 whole cube is equal to 0, which implies alpha is equal to minus 2 minus 2 minus 2. Okay, so here alpha is a characteristic root of multiplicity 3. Okay, so we can have, or we can write alpha 1 is equal to minus 2. Okay, so yeah, we can write, instead of writing alpha 1, let us write just alpha. Okay, so now since it is the alpha is the characteristic root of multiplicity of 3, So the homogeneous solution can be written as ARH is equal to A1 R square plus A2 R plus A3, okay, alpha to the power R. Okay, so here alpha is the characteristic root of multiplicity M. So ARH can be written as A1 R square plus A2 R. Alpha is minus 2 to the power R. Okay, so this is the solution. Okay, so we remember that the homogeneous solution with characteristic root of multiplicity M. So we start with homogeneous solution was written in the last class. We studied about this. ARH is equal to, we had A1, we can have R to the power A minus 1 plus A2 R to the power A minus 2 and so on up to AM. Okay, alpha to the power R. Okay, so since this alpha is a characteristic root of multiplicity M, so we put M is equal to 3 here. So this will become A1 into R to the power 3 minus 1, that is R square. So we got this particular term. Then we got next term, A2 is equal to R to the power 3 minus 2, that is AR2. And the last term is A3. Okay, so from this we got this. The final answer is, so this is the final answer. Come to another example. Find the homogeneous solution for the difference equation AR minus 7 AR minus 1 plus 16 AR minus 2 minus 12 AR minus 3 is equal to 0. So this is the third order difference equation. Okay, so we can write the characteristic equation as alpha q minus 7 alpha square plus 16 alpha minus 12 is equal to 0. Now again we will use the hit and trial method here. Let us put alpha is equal to, let us put alpha is equal to 2 here. Okay, so this alpha q will be 8. 7 into 2 square, 7 into 4 is 28. 16 2s are 2 is 32 minus 12. So this becomes, that is 8 plus 32 is 40, minus 28 minus 12 is 40, so this becomes 0. So we got that alpha equal to 2 is one of the root. So to find out another root, we'll just divide it. Alpha q minus 7 alpha square plus 16 alpha minus 12, we'll just divide by alpha minus 2. It is because alpha minus 2 is the factor of this left hand side of this equation. Okay, so here we have alpha square, multiply alpha square with alpha minus 1, alpha minus 2, will get alpha q minus 2 alpha square. So this will be cancelled out. This becomes minus 5 alpha square plus 16 alpha. Okay, now we have to multiply 5 alpha, minus 5 alpha with this alpha minus 2 will get minus 5 alpha square. This minus into minus is plus, it is plus 10 alpha, cancel out. So this becomes 6 alpha minus 12. Okay, so we just multiply 6, will get 6 alpha minus 12 equal to 0 here. Okay, so the left hand side can be written as alpha minus 2 into alpha square minus 5 alpha plus 6 is equal to 0. Now let us factorize this particular term. So this minus 5 alpha can be written as minus 3 alpha minus 2 alpha plus 6. Okay, take alpha is common here. This is alpha minus 3. Take minus 2 is common here. It is alpha minus 3. Okay, so we can have alpha minus 2, alpha minus 3, alpha minus 2 is equal to 0. So we have alpha minus 2 square alpha minus 3 is equal to 0. So we got alpha is equal to 2 comma 2 times, because this is square here, and alpha is equal to 3. Okay, so we got three roots of the of this characteristic equation, where this root is the multiplicity of 2. This 2 is the root of multiplicity 2, because this 2 is repeated twice. Okay, so and this 3 is the distinct, this is a unique root of this characteristic equation. So the homogeneous solution can be written as ARH is equal to, so let me write it down in another way. Alpha 1 is equal to, let's suppose 2 comma 2, and for 2 is equal to 3. So they are the roots. Okay, so now it can be written as A1, okay, r to the power m minus 1. So first we'll write down for this particular root 2 of multiplicity 2. Okay, so this is A1 r to the power m minus 2, where m is 2 here because 2 is repeated twice. So m minus 2, that is 2 minus 1 is 1. Okay, so let me write down 2 minus 1 plus A2 r to the power 2 minus 2, that is 0. Okay, so this repeated root is 2, so 2 to the power r, plus this is the distinct root, so this is A3, 3 to the power r. Okay, so the homogeneous solution can be written as A1 r, this one is r, plus A2 r to the power 0 is 1, 2 to the power r, plus A3, 3 to the power r, where A1, A2, A3 are the constant that will be determined by the boundary condition. Okay, so this is the answer, we got it. Okay, so this much for today. Thank you.